Today we will be exploring the texture array workflow. This is an advanced topic requiring significant technical understanding of shaders and rendering. Texture arrays are similar to atlases. The Texture Baker component can generate either texture arrays or atlases. The baked texture arrays and combined material can be used with any of the mesh baking components, including the Mesh Baker, Multi-Mesh Baker, and Batch Prefab Baker. Almost all shaders are written to use regular textures. Shaders need to be modified to use texture arrays. Using texture arrays in a project usually requires two versions of each shader. One shader that uses regular textures for the initial level design, and another shader that uses texture arrays. This shader is used once the scenes are finalized and the mix of textures used in a scene is known. The Texture Baker component bakes materials using the regular texture version of the shader into a combined material that uses the texture array version of the shader. The Mesh Baker component or Batch Prefab Baker component then combines meshes and modifies them to use the generated texture arrays. Modifying shaders to use texture arrays is beyond the scope of this tutorial. The Unity manual describes how to modify shaders to use texture arrays in the section Texture Arrays. Mesh Baker includes an example simple unlit texture array shader. It can be found in Mesh Baker Examples Unlit Texture Array. An example standard shader that has been modified to use texture arrays can be found at this GitHub link, also in the description. This has been distributed as a Git project so that it is easy to see the modifications that have been made by comparing the current code with the original check-in. Shader graph shaders can also be modified to use texture arrays using the Sample Texture 2D Array node. Here's a simple shader graph shader that samples a 2D texture array instead of a regular 2D texture. In this tutorial, we will use the standard shader that uses regular textures and a version that uses texture arrays. Consider an example scene like this that has 4 buildings using around 30 different materials. These materials use regular textures, not texture arrays. They're using the standard shader. We'll use the Texture Baker component to combine the textures on these materials into texture arrays, and then the Mesh Baker component to bake the meshes so that they can use the texture array version of the standard shader and the baked texture arrays. In this example, we bake the meshes in the scene. However, we could use the baked texture arrays with the Batch Prefab Baker as well. Notice that some of these meshes have multiple materials and use a lot of tiling. Let's get started. First, create a Texture Baker and Mesh Baker component. Then add objects to be combined. See the Tools for Adding Objects tutorial for more info. Set the result type to texture array and create empty assets for the combined material. Set the shader on the combined material to the texture array version of the standard shader. For best results, the shader should have the same property names as the source material shaders. Now we will configure the material to slice map. Each source material will be mapped to a slice in the texture array. The easiest way to configure slices is to use the button Build Texture Array Slices from Objects to Combine. Before building the slices, set max atlas size to the desired height and width of your texture array. All materials on the source models will be organized into slices. Textures smaller than the max atlas size may be grouped into atlas slices, or they might be scaled up. Most of our source textures are 1024, so we'll set the max size to 1024. Now I'll click the button and generate our slices. Don't be afraid to experiment. You can modify the configuration after it's been created, or delete the generated slices and recreate them. I know that some of the textures like this brick require a lot of tiling, so I'm going to move them to their own slice. Click the Report Texture Sizes button to generate a useful list of all textures used by the slices, their formats, and their sizes. You may choose to remove some objects from the configuration if their textures would be downsized unacceptably, or if they are in a format that's not compatible with other textures due to the wrap mode, channels, compression format, or size. Notice that most of our source textures are 1024, but the brick wall is 2048. It'll be downsized to 1024. If the downsizing is unacceptable, we could remove this texture from the texture array, or we could increase the max size of the array. If we increase the max size to 2048, then the smaller textures will be scaled up, or baked as atlas slices. This could increase our build size significantly. In our case, we can live with the downscaling. Notice that one of the materials uses an alpha channel for transparency. The other materials are opaque. Let's remove this mesh so that our texture array doesn't require an alpha channel. Now let's bake our texture array and take a look at the result. Notice that the first slices contain small textures that have been grouped into atlases. Also notice that textures with a lot of tiling have been put on slices of their own. The tiling has not been baked. They're free to tile because there are no neighboring textures on this slice. Slices can contain more than one texture and source material. These textures will be baked into Atlas slices. Slices can consider UVs. This can be useful for extracting small parts of a large source atlas if props only use a small part. Consider UVs should not be used for props with large amounts of UV tiling. Props with large amounts of UV tiling should be put on a slice of their own that does not use consider UVs, so that they are free to tile. Slices that use consider UVs need a source renderer reference as well as a source material reference. To get good performance from GPUs, it is necessary to compress textures in texture arrays. Unfortunately, different platforms usually require different texture compression formats. For example, Android typically uses compression formats ETC and ETC2. iOS typically uses PVRTC. Desktop PCs typically use DXT formats. Unity does not provide a way to switch the compression format of a texture array once it's been created. This means that a separate texture array must be created for each required compression format. We can create texture arrays in several different formats by adding entries to the Texture Array Output Formats section. Meshbaker lets you define a set of formats, and a copy of the texture array is generated for each format. Assign a name, usually the name of the build platform, for each format. Sometimes there is a need to override the format for some material texture properties. For example, most of the texture properties of the standard shader need 3-channel textures, RGB. However, the emission texture property requires a 4th alpha channel. This can be handled by providing a format override for the emission property. An example setup for this might look like this. Consider this building mesh that uses several materials. How will the renderer know which slices to use in the texture array? The easiest solution is to embed the slice index into the baked mesh. In this example, we will save the slice index for each vertex in an extra UV field. The shader expects the UV channel of each mesh to have 3 fields instead of the usual 2. The slice index can be stored somewhere else in the mesh, such as a vertex color or as another unused mesh coordinate. One advantage of this technique is that submeshes which use different materials can be configured to instead use different slices of a single material. Meshbaker includes a mesh customizer script that will bake the slice index into the UV-Z coordinate. To use the script, create a mesh customizer asset that will assign the slice index to the UV0.Z using the Project View context menu. Go to Create, Meshbaker, Assign to Mesh Customizer, put slice index in UV0.Z. This will create a new asset in the project. Drag this asset to the MB3 Meshbaker inspector and assign it to the Mesh Customizer field. You can also create a custom script that will plug into Meshbaker to assign the slice index to a custom mesh coordinate. To create a customizer script, look at the included example scripts in the Assign to Mesh Customizers folder. Create a similar script, which must inherit from the MB default Mesh Assign Customizer class, that puts the slice index into the desired mesh coordinate. Now we can bake the meshes. The slice index has been added to the combined meshes UV channel. Our texture array shader is using this slice index to look up the correct texture array slice. Each platform, OS X, Windows, Android, iOS, and etc., uses different texture compression formats. Unlike regular textures, texture array assets in Unity do not automatically switch compression format when the build platform is switched. If you're using texture arrays and the project supports multiple platforms, you'll need to write a custom build script that will switch texture arrays when creating a build or creating asset bundles. The texture array manual in the Meshbaker documentation contains some example code that uses the data stored in the TextureBake result to switch texture arrays on a combined material. This code must be in an editor folder or an editor assembly. To use this code, create an editor folder somewhere in the project. Create a script file called mycustombuildprocessor in the editor folder and copy the code from the texture arrays PDF document into this file. You can rename the class and file if you want. Line 27 of the script expects a path to the TextureBake result asset in the project. The code works by querying the list of formats in this TextureBake result. It checks the names of the formats to see if any names match the name of the current build target. If a name matches, then the script assigns the texture arrays for that format to the result material. The script is a custom build processor. This code will be automatically executed every time you create a build with this project. This example code only works with a single TextureBake result asset. You will probably want to modify it so that it can be configured to work with many TextureBake result assets scattered throughout your project. MeshBaker is available on the Unity Asset Store. Visit us at digitalopus.ca for more tips and tricks on using MeshBaker.